Hey guys, so this video is going to be about dilutions. Okay, so now that we know how to make a solution using molarity, moles over liters, we can then have a solution and then make the molarity lower by adding more water. Okay, and that's ultimately called a dilution. Okay, and you can kind of think about this because you would probably know the difference between a diluted drink of Kool-Aid and a not diluted drink of Kool-Aid. A diluted drink of Kool-Aid tastes very watery and gross. You can't really taste the flavor, okay? And that's because you had too much water, right? But you're not changing the composition that you had in your Kool-Aid, and that's why it makes it taste gross, okay? Dilutions look very similar to this in chemistry, okay? When we have a dilution, we're not changing the amount of solute in our solution, right? I'm not changing the number of moles. I'm just changing the volume. So if you think about this, if molarity is equal to moles over liters, okay, and this doesn't change, right, and this changes because you add more water or add more solvent, okay, your molarity is going to go down because remember this relationship is inversely related. So as your denominator goes up, your molarity goes down, which means you have a more diluted solution. Okay. So if we look at this image here, you'll notice that I have 1, 2, 3, 4, 5, 6, 7 moles in this first beaker, and then I have 1, 2, 3, 4, 5, 6, 7 moles in the second beaker as well. The only difference between the two beakers is the amount of water or solvent that is present, okay? So since I've added more water, I'm not changing the number of moles in the solution, I'm just making it more diluted. So this would be like a good glass of Kool-Aid, and this would taste like a really watered down glass of Kool-Aid, okay? And that's ultimately what we're doing when we're diluting something, is we're watering it down, okay? So with that being said, if they're the same number of moles in the solute in each beaker, you're going to have the moles before you add more water is going to be equal to the moles after you add the water. So the relationship is going to be molarity of the first beaker times the volume of the first beaker is going to be equal to the molarity of the second beaker and the volume of the second beaker, okay? And if you kind of think about this for a second, knowing what units you're dealing with, okay, and I'll show you how to write this here in a second, but if you're dealing with units here, molarity is moles over liters, right? Okay, so if I have moles or an initial molarity in my first beaker here, and I multiply it by liters, because it's liters over 1 would be my units for volume, okay? Or here, that's probably confusing. Let me write it like this. The liters of my first one is going to be equal to moles over liters of my second one, so this would be 1, 1, this is 2, times the liters of my second one, okay? So ultimately, this doesn't change. This will, okay? And that's where we'll get a smaller molarity every time something is diluted, okay? Another way that you can think about this is you can say, and I've seen it written like this as well, molarity initially, so I, volume initially is equal to molarity after times volume after. And I've seen them written both ways, but I typically refer to this equation as M1V1 is equal to M2V2. Okay, and that's kind of how I talk about the dilution equation. So I think the biggest thing with these dilution calculations is trying to figure out which volume and molarity go with each other on either side of the equation. Okay, so let's look at some of these and how we solve for these. Here's another thing. It doesn't matter if we're in liters or milliliters as long as our unit cancels, okay? So when we do dilution calculations, we don't have to convert milliliters into liters. We can leave it in milliliters as long as the second volume is also in milliliters. Because if they're not in the same unit, their units won't cancel and we're not going to get an appropriate unit on our answer. So let's look here. So an example, how many milliliters of aqueous, okay, so ultimately I'm looking for volume, okay, of aqueous 2 molar magnesium sulfate solution, okay, so here's another number, solution must be diluted with water to prepare 100 milliliters of a 0.4 aqueous solution. So ultimately, what this question is saying is, in my supply closet, I have 2 molar magnesium sulfate, okay? But I want 0.4 molar, okay? So, and I want 100 milliliters of it. So I ultimately have to figure out how much volume of this 2 molar do I need to get to my final. So our equation is M1V1 is equal to M2V2, okay? So I'm ultimately looking for V1 here because I need to figure out how much I need for my starting solution. So I'm going to be doing 2.00 molar, which is moles per liter. Okay? Hang on. Sorry. Molarity. I'm going to show you something here in a second. Molarity times volume 1, because that's what I'm looking for, is equal to, I need a new molarity of 0.400 molar, and I want 100 milliliters of it. Okay? How do I get V1 by itself? Well, I need to solve for this over here. So I'm going to be doing 0.4 times 100, which is going to turn it into 40. So this is going to be equal to 40. Okay? And then to get the V by itself, you have to divide both sides by 2. So I'm going to divide this by 2.00. So V1 is going to be equal to, watch your sig figs, I think I need 3 of them, okay? Technically it's 20, but it's going to be 20.0. And since I started with milliliters, this answer will also be milliliters. Okay? Now, if you converted this into liters, you would get the same exact answer, except it would give it to you as 0.020 liters, which is the same thing as 20 milliliters. Okay. Let's look at the next one. So number 3 says, how many milliliters, okay, so again, we're looking for a volume, of a solution of a 4 molar potassium iodide are needed to prepare, so I'm making a 250 milliliter solution of 0.760 molar Ki, okay? So I'm, again, doing M1V1 is equal to M2V2, M2V2, and I'm going to plug my numbers in here. Okay, so my initial molarity is 4.00, and I'm trying to figure out how much of that I need to get a solution that is 0.760 molar times, and I want 250 milliliters of it. Okay, so again, I'm going to solve here, so I'm going to do 0.760 times 250. So I'm going to get 4.00 molar times x is equal to 190. And then to get x by itself, I have to divide both sides by 4. So my volume, or my initial volume, is going to be, and I need 3 significant figures, 47.5, and it's milliliters because that's the volume that I started with. Okay, so in order to dilute this solution, I need to go from, I need to have 47.5 milliliters of this, and I'm going to dilute it to this. Okay, let's do another one. Let's look at number 5. I'm going to skip 4. I want you to try 4 by yourself, but let's look at number 5. Because ultimately, we need to figure out how to actually do this process, okay? Because up here, if I look back up at number 3, okay, this is how much of my solution that I need, okay? But if I need 250 milliliters of it, I'm ultimately adding water to get to 250. Okay, so with that being said, to figure out how much water I would need, I would say 250 milliliters, sorry, you can't see what I'm writing, 250 milliliters minus 47.5, and that's going to tell me how much water I need to dilute the solution. I would need 202.5 milliliters of water, okay, because it's an aqueous solution, so that's indicating that it's diluted in water. Now here's the thing. I don't necessarily have to calculate that out because we have volumetric flasks that do that for us. So if I was making this solution, I would get 47.5 milliliters, put it into a 250 milliliter volumetric flask, and then fill to the line with water. And then my solution's made. Okay? So with that being said, let's look at number 5. It says, how could you prepare 500 milliliters of a 0.2 molar solution using only a 1 molar solution of sodium chloride and water? Okay, so we're ultimately diluting to this, starting with this. So we're going to say M1V1 is equal to M2V2, and the molarity that I'm starting with is the 1. Okay, and I'm trying to figure out how much of that I need, and it's equal to 0.20 molar times 500 milliliters. So to get X by itself, I'm going to do this times this divided by 1, which is just going to be its multiplication. So 0.2 times 500. So I'm going to need 100 milliliters of 1.0 molar sodium chloride. Okay? So then my procedure here would look something like this. I would say, step 1, measure 100 milliliters of NaCl in a graduated cylinder. Okay. The next thing I would do is put into a 500 milliliter volumetric flask, because that's how much of the solution I want. Okay. I would then fill to line with water. And that's it. And that's how you would dilute a solution. Okay? So that's it for dilutions, and we'll do some more practice in class. Thanks, guys.